All right, so at the end of this lesson, what I expect you to know is to be able to define mixture. So we're going to be talking about mixture. Be able to define mixture. You need to identify specific mixture types. Some mixtures can be separated using filters. We'll learn more about that as the lesson continues. Understand the difference between a solution and a mixture. Know and understand that various materials, which are substances, may have different physical properties. So these are basically the learning goals for today, all about mixture, and I'm going to thoroughly explain all the content for today. All right, let's go. So what exactly is a mixture? In your chat, take a wild guess and explain to me, what do you think is a mixture? Let's hear some of your answers. What do you have to say about a mixture? Type in the chat section, please. Tell me what you think is a mixture. As I wait for some chats from you all. All right, Kwakanya, it is things that are in one thing together. Kaiten, different things put together. Marola, something that has multiple or different ingredients. All right, great. You guys have a basic idea of what a mixture is. Then we've got Teta, two or more things combined, Charmaine, a combination of different things, and Tando, for example, sand and soil. You guys are perfect. Thank you so much. All right, let's actually find out what exactly is a mixture. All right, so a mixture is two or more different materials that have been mixed together. A lot of you mentioned that in your chat already, that it's actually materials that have been combined and that have been put together, 100%. In some mixtures, the different materials are still clearly visible after mixing. A mixture of peanuts and raisins would be an example of such a mixture. Now, how would we separate peanuts from raisins? In the chat section, how would you separate peanuts and raisins? All right, how would we separate peanuts and raisins? I'll give you just a couple of seconds to answer and then we will move on. All right, Marola says take the peanuts and put them on one side and the same with the raisins. All right, excellent, Marola, very good. Anybody else? Kira, pick out the peanuts. Excellent. All right, thank you so much for your answer. And then Abba says, don't you just separate them because they don't look alike? You're 100% correct. Because they're not the same, we can easily just pick up the peanuts and easily pick up the raisins. All right, and someone said, Ashley, we sort it out by hand. That is a beautiful answer. We obviously sort out the peanuts and raisins by hand. Because we can see the peanuts, we take out the peanuts. And because we can see the raisins, we would remove the raisins. All right, easily by hand. Excellent answers, guys. Thank you so much. All right. Then it says, can you think of other mixtures in which the different materials are so clearly visible after mixing? Think about maybe some of you had breakfast this morning or dinner last night and you had a salad or something. What materials can easily be separated? If it's a mixture, what can we easily separate it by our hands? All right, it says look at the pictures for some ideas. All right, those look really, really good. I haven't had those in a while, hey? Obviously, we can sort these out by color. Someone did mention in the chat, I think it was Rizal mentioned color as well as Leonoro, they mentioned color. So now with jelly beans, we can obviously remove the different colors, the orange, the pink, the red, and separate them. All right, excellent. Then we've got a shell. Obviously, we can separate them by the color or the shape that they are. And we can obviously easily pick them to separate them. All right, that's mixtures. And lastly, we've got some ducks and swans. You can separate them by putting the swans aside and the ducks aside. All right. Are we all okay with this slide? And any questions about separating mixtures? So remember, a mixture are different materials put together and they're still very, very clearly visible. You can still see the green jelly beans and the orange jelly beans. You can still see the raisins and you can still see the peanuts. All right, those are mixtures that are clearly visible. 100%. We're going to move on now to the next slide. All right, so now separating mixtures. So now how exactly can we actually separate mixtures? We don't have to always use our hands. I mean, imagine trying to separate salt and sand with your hands. When are we going to finish, right? Very, very impossible. Now it says, with a mixture, the different substances are clearly visible and can be separated from each other. All right. Now, there are 4 methods of separating substances in mixtures. All right. Now, I need you to remember the 4 different methods of separating mixtures. The first one is hand sorting. All right. You can separate mixtures with your hand. A lot of you have mentioned that you can separate them by color or their shape. Thank you very much, Tato, for that. And Gwakanya said granola and strawberries. All right, there we go. I think you had that for breakfast. That sounds like a delicious, healthy breakfast. Awesome, Gwakanya. So you can separate them by your hands, granola and strawberries. That's the first thing, hand sorting. The second one is sifting. Now, a sifting, I'll show you pictures later, is basically when mom bakes and she's got flour and sugar and she does this to sift particles. That's how we can actually separate mixtures by sifting. For example, sugar and rice. Then we can also filter. That's also a good way to separate mixtures. And the last one is settling and decanting. Now, just to explain decanting, it's basically to put mixtures or substances inside a jar. Let's make it a glass jar. And you might find that all the heavy substances sink to the bottom, and at the top is all the liquids. All right. Remember those 4? We will be doing a very quick quiz at the end, and maybe this question might come up. The 4 methods of separating mixtures: hand sorting, sifting, filtering, and then settling and decanting. All right, let's move on. Alrighty, so we're going to carry on with mixtures. Now here's a couple of examples of mixtures. There's a salad. Now obviously, how can I separate that salad? It could be by color. It could be by fruit. Maybe I want to put fruits one side. Maybe I want to put the vegetables on one side. All right, but I can easily hand sort them. All right, I can easily remove the strawberries, remove the lettuce, remove the olives, and put them all in separate spaces. That's what we call by separating mixtures. Then some really delicious biscuits. Who loves biscuits? I do. I love biscuits with a cup of tea. All right. Now we can easily separate those biscuits by their shape, by their color, all right, or maybe by their taste. All right, so we can easily hand sort them. And lastly, a cake over there seems to have some sort of fillings inside. We can easily remove those fillings if you not want to eat them. All right, mixtures are absolutely everywhere you look. Most things in nature are mixtures. Look at rocks, the ocean, or even the atmosphere. All right. Right, again, Tato. Tato says you can separate the biscuit by their shape. Now, I want you to have a look around where you are now, around the room, around wherever you are doing this and watching this live. What is around you that is actually a mixture that you can easily pick out with your hand? Type it in the chat box. Look around you. There's mixtures. Where do you see a mixture? I'm trying to look around as well. Maybe I'll see something that needs to be a mixture. Right, where do you see mixtures around you? Ah, Kira, a jar of sweets. Wakanya, my pens and pencils. Yes. Lazal, a smoothie. All right. Whew, look at all these chats coming. Excellent. All right. Then we've got Lerato says tile. Alexi said fruit. All right. Beautiful, beautiful. All right. Let me just attend to Puleng. Puleng, please ask your question in the chat. I'm aware that you raised your hand. Abo says a box of batteries and earphones. Excellent. All right, crayons, biscuits. You guys have got the idea. I'm so proud of you. Well done. All right. Those are mixtures around you. I'm not sure I look around me as well. I have a big basket of balls. I've got netball balls, basketball balls. So I can actually remove those according to their uses. Put netball balls aside, soccer balls aside, cricket balls aside. All right. That's an example of a mixture. All right. Excellent. All right. Let's go. Right. Then it says there are infinite number of mixtures. Anything you can combine is a mixture. Think of everything you eat. Just think about how many cakes there are. Each of those cakes are made up of different mixtures and ingredients. Just like I gave you the example now of that cake with the fruit filling, that is a perfect example of a mixture. All right, the fruit salad and the biscuit. Right, next slide. Going to carry on with our mixtures. A mixture consists of at least two different substances mixed together. All right. In some mixtures, the different substances are so clearly visible after mixing. Now, if we look at this, now I've been drinking some water. If I told you, I mean, you can't take a wild guess whether in this bottle is water and sugar or water and salt. You wouldn't know. But this what we call, this would be a solution because you cannot see what is inside the bottle. All right. Anyway, but it says that in some mixtures, the different substances are so clearly visible after mixing. This over here would not be a mixture. You cannot physically see what is in here. You can see that it's water, but you don't know what I mixed it with. Unless, of course, you could see the strawberries and the oranges, then it would be a mixture. But in this case, you cannot see what is in here. All right. Perfect. Oh, this is puzzle. That's a very good one. Puzzle is a very good example of mixtures. All right. The substances in such mixtures can be separated by physical means, such as sieving. This is an example of a flour trying to bake. All right. Filtering, hand sorting, settling, and decanting. We have spoke about that already. All right, here's a perfect example. We've got some salt and some black peppers over there. Now, please tell me, can I hand sort the pepper and the salt? Yes or no? Tell me in the chat. All right. No, of course not. Teza said no. Marola said no. All right. Excellent. So I obviously cannot physically sit and remove the salt and remove the pepper. Now imagine how long that would take me. All right. Who's
Guys, it seems Karaba had some technical difficulties. She'll be back in just a moment. Garaba, you back?
All right, I'm back. All right, I'm back, Melanie. Thank you so much. All right, sorry about that, everybody. Technical glitches. I hope you can all hear me. Just say yes in the chat. Just make sure you can all hear me. Please just type yes in the chat if you can all hear me. All right, perfect. Thank you so much. All right, I'm very, very sorry about that. All right, so before I left, I actually asked if we can separate black pepper and salt using our hands. My answer was it's going to be extremely difficult to do so, and we would obviously need to sift through to remove the salt and the pepper. All right, it would take you a very, very long time if you had to remove the salt and the pepper using your hand. So one method that we use for that would be to sift through the material. All right. Next slide. Mixing mixtures. All right. Now it says making mixtures include two solids, salt and sand. It could be sugar and tea leaves, peanuts and dried beans, different kinds of coins, and a mixture of different sweets. All right. So this is an example of making mixtures. All right. So we can make mixtures including two different types of solids. We can mix salt and sand to make a mixture. All right. That we can separate by sifting. Sugar and tea leaves. We could also separate those by sifting. Peanuts and dried beans. Different kinds of coins. You can put 1 rand coins aside, 2 rand coins aside, and a mixture of different kinds of sweets. All right. We can also make a mixture by mixing a solid and a liquid. This could be sand and water or chalk and water. These are just mere examples. And obviously it could be curry powder and water, grated cheese and milk. And lastly, we can also make mixtures by mixing two liquids, which is oil and water. All right. Now, this is just an example of how we can make mixtures. All right. All right. So now I've got a little fun activity for you to do. All right. But you're going to have to do this in your own time at home. All right. This is just something for you to practice and actually just physically see if it's physically possible to do what I expect of you to do. All right. Someone asked, is chakalaka mixtures? All right. Now, let's take a wild guess. Let's think of chakalaka. Chakalaka is mixed up with carrots. It could be beans. It could be, what else is in chakalaka? It could be tomatoes, all right? So it is a mixture, yes, because there are different substances inside to make chakalaka. Thank you so much for that question, Charles. Chakalaka is a mixture. We can remove the bits of carrots and the bits of beans and the bits of tomatoes. All right. So thank you so much for that question, Charles. Awesome stuff. All right. So I was saying that you're going to have a fun activity to do at home. Obviously, you need to ask your parents for permission to do so, but it's going to be very, very fun. All right. So what you need to do is you need to place 10 scoops of sand in a mixing tub. So since we've all been on lockdown, we can't go anywhere, but how about just take a walk in the garden and grab 10 scoops of sand and put them in an old tub, an old ice cream tub or something that mom is not using, all right? 10 scoops of sand in a mixing tub and also 10 scoops of sugar in a mixing tub, all right? Sand and you've got sugar, all right? Not a lot of sugar, just 10 small scoops, just a teaspoon and a teaspoon of sand. Mix all of that together until you get a mixture, all right? Then I would like you to draw a picture of the mixture. I know I'm sure there are very, very good drawers in this video chat with us, and I'm sure you can draw a perfect picture of a mixture. Draw a picture of sand and the sugar. All right. Then I would like you to tell me if you can separate the mixture into a pile of sand grains and a pile of sugar grains. Now remember, you have mixed sugar and salt in a tub that you've asked mom to borrow and some sugar to use. You've mixed it all up, all right? Now you need to try and separate the sugar and separate the salt. And ask yourself, if you had to physically do this with your hand, how long would it take you to separate the sand and to separate the sugar one by one? And actually, which method of sorting would you use to separate sand and sugar? Now, in your chat, how about you tell me, out of the 4 methods we spoke about earlier, which method would you use to separate the sand and the sugar? All right, I would say it would take a year or 2 to separate sand and sugar. That's a good one. All right. Sieving, well done, Charles. We could use sieving. Anything else? Who thinks that we could use something else to separate sand and sugar? Anything else? Right, yes, sifting. Very, very good, Kira. A lot of you are saying sifting, and that is 100% correct. All right. So if mom has a sifting, you can just ask her to please use a sift and try and separate the sand and sugar. All right. There we go. This is just something fun for you to do. I would encourage you all to do it. It just helps for you to understand mixtures a lot better. All right. And obviously, do you think it would be possible to separate the mixture using a sieve? Why do you think so? Now, a sieve is just the item at the bottom right. That is what a sieve is. Would it be possible to remove the mixture, to separate the mixture using a sieve? All right, so please, whenever you've got time and you're bored, which you shouldn't be, right? Do this fun activity. Remember to ask for permission first to use the sugar and to just get a bowl to mix it all up. All right, that would be excellent. All right. You can, Leonora asked if it's tablespoons or teaspoons. You can just use a teaspoon. A teaspoon is okay for you to just add. A teaspoon is perfect. Or you can use a tablespoon for bigger amounts. But I would just suggest 10 teaspoons of sugar and 10 teaspoons of salt. Good question. Thank you so much. All right. With the slide, I would like to move on. All right. Next. All right, someone just asked me, Leonosa, please excuse pronunciation. They asked, what are fortified foods? Now, fortified foods are foods that have added nutrients in them. So they do not have nutrients and you need to add the nutrients. All right, those are what fortified foods are. All right, remember, if you still have any questions, please do ask in the chat and I will respond to you. All right, thank you for that question, Letty. Awesome. All right, let's do this activity now. All right, so we spoke about a mixture. So we know what mixtures are. A solution with water. We haven't really discussed solution. We will do that another time. And I was drinking a cup of tea, all right? This would be just with this tea and sugar mixed together, the sugar dissolved in the tea, making this a solution. All right. Now, let's look at the first one, sugar and water. Is that a solution or a mixture? Type in the chat, sugar and water. A solution or a mixture? Kira, solution, good. Marola, solution. Charles, solution, excellent. Abo says a solution. Oh, look at all these coming in, all right. Awesome, a lot of you are saying solution. All right, Charmaine, Lutando, Netefato, Aiden, Olwetu, Tedza, well done. Sugar and water is a solution. Thank you so much for your answers. What about salt and water? Is that a solution or is that a mixture? All right, Lacan, solution. Sierra, solution. Faith, solution. Lizelle, solution. Yes, right, so salt and water is a solution. Thank you all for actually answering the question. What about sand and water? Is that a solution or is that a mixture? What about sand and water. All right, Faith says a mixture, and we've got everybody coming in as mixtures. Well done. All right, and someone says it depends on how much sand you put in it. All right, very, very good. That's a very, very good point. All right. If I put in about a teaspoon of sand in this, it will obviously all sink to the bottom. And the only way to separate that would be either through sieving, all right, or filtering. Good point that you've put out there. The next one, oil and water. Would that be a solution or a mixture? All right, would that be a solution or a mixture? Let's see your answers. Kira said, if something dissolves, sorry, I missed that question. Kira, please just type it again or let me scroll up. Oh, I missed your question, Kira. Please type it again. All right, awesome stuff.
All
right.
The thing it's mixed in, does it become a solution?
Sorry, please say that again, Melanie.
If something dissolves in the thing it's mixed in, does it become a solution?
Yes, yes, it does. Kira, yes, it does become a solution. So if I mix some salt in this and the salt dissolves, it has become a solution. Thank you so much for your question, Kira. All right. Vinegar and water would be a solution. It's a pleasure, Kira. All right. Flour and water, would that be a mixture or a solution? What about flour and water? A mixture or a solution? All right, a mixture. A lot of you are saying mixture. All right, let's find out the answers to see what is what. All right, so you all basically said that salt and water, sorry, sugar and water is a solution. Salt and water is a solution. Sand and water is a mixture. Oil and water is a mixture. Vinegar, and just to explain oil and water, you can actually physically see the oil inside the water. So if you're making some pasta and mom adds some oil, you can actually see the oil floating at the top. Vinegar and water is a solution. Flour and water is a mixture. All right, excellent, excellent. All right. Now, what would I like you to take away for this lesson? I want you to be aware that when grains are large enough, we can separate them by hand. That could be beans, that could be fruit salad, that could be, trying to think, this could be large grains of black pepper, all right? So if grains are large enough, they can be separated by hand, all right? And when grains have two materials of different sizes, they can be separated by sieving, all right? So smaller particles such as sand and salt, it would be easier to separate them by sieving. Particles such as beans and jelly beans, we would need to separate those by hand. All right. Thank you. Tando said, what about powder and water? So are you asking me if powder and water is a mixture or solution? All right, so powder and water would be a mixture, all right? Most of the time, the powder would float at the top. You could always just scoop it out with a spoon. All right, I hope I've answered the question, Tando. So powder is not as heavy as flour. Powder is a very, very light substance. It would end up floating at the top of the liquid. All right, so just remember that large materials can be separated by hand, and smaller ones, it would help to sieve them through. All right, very good question. You are right, Marco. All right, it's a pleasure, Tando. All right, we've come to the end of the lesson. Please do follow these links to help you understand mixtures. You'll find this on YouTube, and a video also how to separate sand and salt. This would help you in the fun activity that I've given you to do at home in your spare time, for you to be able to separate sand and salt. All right. All right, and we all said, but if you mix it, it makes dough, right? So now, are you talking about flour as well? So if you mix water and flour, it makes a very thick dough, depending on how much you mix. All right. That's would be a mixture because you're trying to make a cake or bread. So these are helpful links for you for mixture and separating sand and salt. All right. So next week, sorry, not next week, next lesson, I apologize for that. We are going to be discussing solutions, like this bottle of mine, and special mixtures. So please do tune in. Our lessons are always a continuation for you to understand the theory better. So today we spoke about mixtures, and next week we will be discussing solutions as special mixtures. I'm very, very excited for that. All right. Please remember to follow us. If you've got any questions, you can just email me. That's my email over there. Follow us on social media at Africa Team Geeks and at hashtag Lockdown eSchool and at GBE South Africa. Thank you so much, Great Sisters, for being amazing, for your beautiful questions. You've all done so well today and behaved so, so well. Keep up the good work and have an awesome Wednesday. Goodbye.